When we differentiate a function, we get a new function in return, right? The derivative. If this function is also differentiable, then there's no reason why we couldn't differentiate again to get f prime prime. Notationally, we drop the brackets and just write this as f double prime. Now, of course, we could differentiate f double prime to get f triple prime, and so on and so forth. Eventually, though, this notation starts to become rather cumbersome. Imagine trying to count out the number of ticks on the 10th derivative. I suppose you could get creative and collect these in groups of 5, but we want a better system. Thus, we will denote the nth derivative of the function f as f to the n like this. Here, the brackets make it clear that this isn't a power, but rather a derivative. Okay, let's find the fourth derivative of the monomial x to the power of 8. All we're going to do is just keep on differentiating until we've managed to do it 4 times. The first derivative is an application of the power rule. The second derivative is the derivative of the first derivative. Again, this is a power rule application, but with an extra coefficient. The same story holds for the third derivative, though multiplying the coefficients is starting to get a bit trickier. And finally, the fourth derivative, where now I've had to resort to a calculator to make sure that I get the number 1680 correct. Sometimes we can find a general formula for derivatives. Let's give it a try on the function x plus 1 e to the x. In these sorts of cases, we're going to differentiate until we find a pattern, then try to write that pattern down in general. The first derivative is a classic product rule, which we've done before in another video. The second derivative looks strikingly familiar to the first, with just small differences. The third derivative is pretty much the same thing, and I'm going to go through it just so that we can be confident in our pattern. Looking at our answers, there seems to be a pretty clear pattern here. The key, though, is to be able to write that pattern in terms of the number of derivatives that we've taken. Notice in the third derivative, we see an x plus 4. And in the second derivative, we see an x plus 3. In the first derivative, an x plus 2. This suggests that the nth derivative should have an x plus n plus 1 term. And that's our answer. Higher order derivatives show up a lot in applications. We can't say much about them quite yet, but it's good to know that they exist.